Oh, hi. Great to see you there. I'm Mason Coon. Welcome back to another episode of Spectroscopy.
I'll just start with the mass spec here. We can see the base peak and then plus. Mass of this molecule is 214. The only mark I got here was the difference was 93, but it recommended a bromine, which is not in the formula, so we could see it's C13H10O3, so it does not apply. So the next thing we can do is degrees of unsaturation, which is 2 times the amount of carbons, plus 2, plus nitrogens, minus hydrogens, minus the alkyls, divided by 2, and we got that to be 9. So as we're looking at it, we're going to assume that there's going to be a lot of rings and double bonds. As you look at the IR here, I already have the zones mapped out. The first one here, you can see there's nothing going on, so I put nothing. Second one, there's a lot of action. This signifies that there's an alcohol with 2 benzene rings, and they're connected with an oxygen in the middle of that. As we go to 3, you can see there's nothing going on. 4, it's pretty steep. Goes all the way down here. That's a strong carbonyl signal. 5, same thing. That signals that there's an aromatic. And I also went into the fingerprint on this. The lowest one here is at 1188. That recommended that there's an ester in the group. I also did 750, and it suggested alkene, which we will see in the benzene rings. As you look at our proton NMR here, I'm going to make sure that we have the amount of hydrogens. First one up here, 1. These are so condensed together, so I made another graph of it. Got one here, 1. This one signaled a 2 due to its height. Another one here. This one's also 2 due to its height, and then 1 here. So got that 1 up here, and then these 9 equals 10. That's how much we had in the molecule. So if we start to look at this, start with the most electronegative, which is up here. It signified the alcohol, which I believe shifted so downfield due to the ester. This, you can see it right here. This first hydrogen right there. That's why it's number 1. Because it's connected to the oxygen, it's most electronegative. Then 2 through 10 all signal from an aromatic. So 4 has 2 of them, and also 6, which rounds out the 9. So if you look at that here, you can see that all of these here, these hydrogens, are connected to those aromatics. As we move into the carbon-13 NMR here, I worked it from the most electronegative at A to the least electronegative at K. So if we start with the most electronegative, we see that's an ester. It's due to the 2 oxygens coming off of it here, so that's A right there. So we look at B, here at 162, that signifies that it's an alcohol. And this is the next most electronegative, so B right here, that carbon going to the alcohol. And then C through K is all aromatics, but C is next at 150 due to it touching, this carbon here touching part of the ester. So as we go D through K, all here, these signify aromatic. Just kind of depends on it. Most of them went over here due to the effect of the oxygens, and this one was kind of untouched, is why you see the letters that are farther down in the alphabet.
Well, I'm Mr. Coon. That wraps it up for Spectroscopy.